Hello everyone, welcome to my lecture. I hope all you are doing very well. In this video, I'm going to introduce customer lifetime value metric. Customer lifetime value is called CLV or sometimes LTV. They are perfectly exchangeable, but in this video, I'm mainly using LTV to avoid confusions. Are you ready? Then let's get started. We have learned individual customer level profitability metrics. Particularly, size of wallet and share of wallet are the key metrics in that individual customers' profitability can be decomposed into those metrics and they offer a useful framework to develop marketing strategies. However, size and share of wallet reflect transactions at a specific time or during a short time period, like a snapshot photo of a boy running continually. If a customer shops regularly and shows a clear pattern of shopping, the size and share of wallet are still useful to characterize profitability of the customer. Let me use the snapshot analogy. If the boy is running constantly in one direction, the snapshots of this boy are very similar to each other, and one snapshot is enough to understand his movement. Like this, if a customer's shopping pattern is constant over time, just one observation of her shopping is enough to understand it. But it is not always guaranteed that customers shop regularly. Even though we know that David has spent $1,000 for his grocery shopping at Kroger, but we don't know what will happen in the future. It is possible that he increases or decreases his size of wallet in the future. Also, customers may switch brands in the future, meaning that the share of wallet can be changed. In addition, customers may become dormant and come back again. All of these cases are like a boy running in random directions. Of this boy, the snapshots totally differ from each other, and one snapshot cannot describe all of his movement. That is, the size or share of wallet at one specific time are not always enough to measure profitability. Here is an example. Suppose that there are two customers and this figure shows their transaction history. X-axis stands for time and Y-axis stands for the dollar value of each transaction. Customer A made small size transactions at the beginning and she left for a while and then she came back with transactions of a large amount. And customer B also shows a change in her transaction pattern. It seems to me that she just missed shopping a couple of times unlike customer A, but she has reduced her transaction over time. So, size and share of wallet at this moment do not reflect customer A's large amount of recent transactions and customer B's smaller amount of recent transactions. That is, they are not enough to measure these customers' values over time. Then, how to measure the customer value or profitability that fluctuates over time? Now, I'm going to introduce customer lifetime value metric, which is very popular in practice to measure the fluctuating value. To understand this metric, the first thing you have to know is the present value concept, which is generally used to account for the value of time. Let me start with an example. Suppose that there are four friends, Alice, Emma, Isabella, and Olivia. Each of them is expected to spend $5,000 in total during the next 5 years. But the amount of spending in each year varies across these guys as follows. Alice is expected to spend $1,000 equally in each year. Emma is expected to spend all of $5,000 in the first year, whereas Isabella is expected to spend all in the last year. Olivia is expected to increase her spending by $500 over the years. Question is, who is the most valuable customer for the 5 years? How do you think? Alice? Emma? Isabella? Olivia? Or Ty? Because they all will spend the same amount of money for the years? Answering this question may not be simple. Then, how about this? This is much simpler. Here are 2 gift options, and you can choose either of them. One is receiving $1,000 today, and the other is receiving $1,000 next year. Out of these 2 options, which one do you prefer? I am 99% sure that all of you choose the first option, receiving the money today instead of the next year. Why? The amount of money is the same, but when you choose the second option, you have to wait a year. Then, let's decrease the amount for the today option. How about $950? How about $900? How about $850 today? And what is the amount of money for the today's option, which makes you feel both options equivalent to each other? Maybe it's still not simple, so one more assumption. Suppose that you are a really good investor and you expect 10% rate of return from your investment. That is, if you receive $900 today and invest it for a year, you will have $900 times 1.1, which equals to $990 next year. In this case, you'd better to take $1,000 next year. But if you receive $910 today and invest it for a year, you will have, in the same manner, $1,001 next year. It flips over your choice. You'd better to take $910 right away instead of take $1,000 next year. So, we may find the equilibrium using the following formula. At the equilibrium, your investment of the money received today, which equals the amount of money received times 1.1, makes $1,000 next year. With a simple math, the amount is given by $1,000 divided by 1.1, which equals 909.09 That is, with the 10% of rate of return, receiving $1,000 next year is equivalent to receiving $909.09 today, and this value, $909.09, is called the present value, in short PV, of receiving $1,000 next year. The rate of return is usually called discount factor because it is the rate of discounting the value of future money. With the smaller discount factor, the value of the future money becomes higher. For example, the present value of receiving $1,000 next year becomes about $950 with the 5% discount factor, and it is about $990 with the 1% discount factor. The present value denotes the point at which you change your choice. If you receive less than the present value, you'd better to receive $1,000 next year. But if you receive more than the PV, taking the money right away is the better option. Then, what will happen if you receive the money 2 years later instead of the next year for the second option? We can compute the equilibrium in the same manner. For example, when you receive $800 today and invest it for the next 2 years, you expect $800 times 1.1 times 1.1, which equals $968. This is less than $1,000, so you'd better to choose the second option. And we have the following formula at the equilibrium in the same manner. At the equilibrium, your investment of the money received today, which equals the amount of money received times 1.1 and times 1.1 again, makes $1,000. With a simple math, the equilibrium value is 826.45. So, if you receive less than this amount today, you'd better to choose the second option. But if you receive more than this amount today, taking the money today is the better option. The present value concept allows us to compare the value of money between different time points, and we can apply this concept to the example at the beginning. We have 4 people and cash flows from them for the next 5 years. And the strategy is as follows. You can compute the present value for each amount of money in each year and add up the present values. The sum is the net value of all money after discounting the value of the future money. Then let's do this. First, compute the PV of each transaction. For simplicity, assume that discount factor is 10% per year. The table looks like so complicated, but when you carefully look at it, you can find that each cell is just a simple math. For the first year, all transactions are discounted only once, so they are divided by 1.1 only once. For the second year, all transactions are discounted twice, so they are divided by 1.1 twice. Doing the same thing for the rest of years, dividing by 1.1 3 times for the third year, and 4 times for the fourth year, and 5 times for the fifth year. You have the present value of each transaction. Next, add up the present values. For Alice, the sum of the PVs is $3,790.79. This is called the net present value, in short NPV, of her transactions expected for the next 5 years. The NPV of Emma's transactions is about $4,500, and for Emma, the NPV is relatively so low, about $3,100, and for Olivier, the NPV is about $3,400. So, in sum, Emma is the most valuable, followed by Alice and Olivier, and Isabella is the least valuable, even though all of them are expected to spend the same face value of money for the years. And why? Because of the value of time. The later the money expected, the more the value discounted. Emma is expected to spend all of $5,000 sooner, so she is the most valuable. But Isabella is expected to spend all of it later, so she is the least valuable. This strategy using the present value concept also can be applied to past transactions. Consider you received $1,000 last year. Then, how much is that money worth today? Still using the same discount factor, 10%, you will get $100 more from the investment, so the money you received is worth $1,100 now. If you received $1,000 2 years ago, in the same manner, it is worth $1,210 now, which equals multiplying $1,000 by 1.1 twice. Then, let's apply the strategy to Alice's past transactions as follows. She spent $800, $700, and $900 3 years, 2 years, and 1 year ago, respectively. She also spent $1,000 this year. And suppose the same discount factor, 10% per year. First, compute the present value of each transaction. It is simply given by a multiplication by a rate. For the money spent 3 years ago, each present value is equivalent to the value of investing it for the 3 years. This is the formula to compute the present value, which is $1,064.80. In the same manner, the PV of the money spent 2 years ago is about $850, and that for the last year is $990. For this year, we don't need to compute because $1,000 itself is the present value. Second, add up the present values. Then the sum is about $3,900, which is the net present value of Alice's past transactions. So far, I have introduced the present value concept. It enables us to evaluate an amount of money at any moment in current dollar value. This value is adjusted to account for the value of time. Thus, the value of the money expected in the future is discounted, whereas that of the money already realized in the past is inflated. Now, I'm introducing an application of the present value concept to measure the customer value over time. It is very similar to what I have already explained. Basically, expected or realized margins from customers replace for the face values of the transactions in the previous tables. PCV, LTV, and CE. What I'm introducing here are these three terms. Past customer value, in short PCV, lifetime value, in short LTV or CLV, and customer equity, in short CE. Conceptually, PCV and LTV are the net present value of past contributions and expected contributions, respectively. First, let's start with PCV. The mathematical expression of the PCV of a customer is this. It looks so complicated. Yes, I agree. It is very, very complicated. But conceptually, it is the same as the net present value computation. Let me point out two components in this equation, GC and delta. GC is gross contribution, which denotes realized profit from a customer, and delta denotes the discount factor. Again, this equation is very complicated. I don't want you to memorize this equation. My recommendation is to conceptually understand the steps of PCV computation. How? Like this. PCV is basically a sum of gross contributions over time. But at each time, the gross contribution is inflated by the discount factor. Here is an example of PCV computation. Here is a 5-month history of past sales from a customer. Suppose that we are at the end of May. The first step is to compute the gross contributions. Here, we don't have information about costs, so we cannot compute the exact profit from the sales in each month. Instead, the 30% contribution margin is given. That is, profits are about 30% of the sales value. With this margin information, we can compute the gross contribution in each month. The second step is to compute the PV of each gross contribution. This is a monthly history, so we need a monthly discount factor. Here, 1.25% monthly discount factor is given. With this discount factor, we can compute the present value of each gross contribution like this. The last step is to compute the NPV, which is the sum of the present values. This NPV is the past customer value, which is what we want to get. So, the computation of PCV is the exactly same as the previous example of computing NPV of past transactions. Transactions values are replaced with gross contribution, and that's it. Now, let's move on to lifetime value. Again, mathematically, LTV is expressed in a complicated equation like this. You don't need to memorize all of this formula. It's wasting of time. Rather, just try to conceptually understand the equation as follows. LTV is also sum of the gross contribution over time, but those contributions are expected in the future, so they are discounted by the discount factor before summation. This is the basic model of LTV. In practice, managers usually take into account two more components, acquisition cost and retention or survival rate. To acquire a customer, there always were costs. The acquisition cost is a one-time cost incurred at the point of acquisition, and differs from direct costs and marketing costs to serve the customer and make sales. So, the acquisition cost must be subtracted from NPV of contributions to get the exact lifetime value. For example, even though there is a $1 million valued customer, she is not profitable when you spend more than $1 million to acquire her as your customer. Also, some customers will leave. More precisely, all customers will leave. The key is when they leave. Some of them leave sooner, but some of them stay for a long time. This implies the future contribution is probabilistic, not for sure. We already have a good metric for this probability, survival rate. Survival rate denotes the probability of still staying as an active customer. Here, this SR is the survival rate. By multiplying the gross contribution by the survival rate, we can account for the probabilistic nature of the future contributions. For example, suppose that there is a customer who is expected to generate $1,000 of profits in the next year. But $1,000 expectation is valid only if she will stay next year for sure. If she will leave next year for sure, it is reasonable to expect nothing rather than $1,000. If she will stay next year at a 90% probability, our expectation should be discounted to account for the 10% risk of losing her next year, leading to $1,000 times 90%, which equals $900. And here, AC is the acquisition cost. Please note that the acquisition costs are subtracted after computing the NPV of the gross contributions. The reason is that LTV is generally computed in dollar value at the moment of acquisition. So the face value of acquisition costs itself is the present value. Unlike PCB, all of the components in calculation are expected values except the acquisition cost. We don't exactly know the survival rate in the future, gross contributions in the future, and the discount factor in the future. To determine the values of those components, we have to rely on other information sources such as market reports, public statistics, and internal analysis reports. But the information sources are not always available, and even though they are available, it is still very hard to correctly predict the fluctuations of the survival rates and gross contributions. So, in practice, it is usually assumed that the retention rate and the gross contribution is constant over time in LTV calculation. Then, the survival rate becomes a power of retention rate with exponent t, which indicates the time that has passed since the acquisition. In addition, LTV is usually computed over the infinite time horizon, meaning that the entire lifetime. With the assumptions, the LTV formula becomes a simple form without any summation. It is given by multiplying the predicted contribution at each time period by a multiplier and subtracting acquisition cost. This multiplier is called margin multiplier, which is determined by the predicted retention rate and the discount factor. This form is the popular definition of LTV in practice. You may find exactly the same formula in the case study. This formula is simple, but provides us with a lot of intuitive marketing implications. Because LTV is a metric to measure profitability, enhancing LTV implies improving profitability. Then, when does LTV become high? First, the more the gross contribution, the higher the LTV. This is straightforward because the gross contribution is the amount of profit. Second, the higher the retention rate, the higher the LTV. A high retention rate means there is a high chance to keep customers, so high LTV is expected. Third, the lower the acquisition cost, the higher the LTV. This is also straightforward because reducing cost means improving profit. Fourth, the lower the discount factor, the higher the LTV. The discount factor is the rate of discounting monetary values in the future to account for the value of time. So, if it is low, the rate of discounting is low and LTV becomes high. Please note that firms cannot control the discount factor. It is given by the market and other environmental factors. However, the first three components at least partially depend on firms' marketing efforts. All marketing activities must be developed to clearly improve one of these components. Also, it must be clearly checked that whether the activity hurts one of the components or not. Sometimes a marketing action to improve one component hurts another component. For example, you can offer discount coupons to your customers to enhance the retention rate, but it may reduce the gross contributions from the customers. LTV is a metric for an individual customer. Customer equity is a simple summary metric of the LTVs across customers. It is given by the sum of the LTVs of all customers, which indicates how much the firm is worth based on the profit expected from each customer in the future. Alright, that's all I have in this lecture, and let me wrap up with a short summary. Past customer value is how much a customer has contributed to profit over time. In order to develop future marketing strategies, it is necessary to know how much customers will contribute to profits over time, that is, lifetime values of the customers. PCV and LTV are conceptually on the basis of net present value, which reflects the value of time. In practice, activities and costs for acquisition and retention are additionally considered.